Ganesh. Welcome to my study room. Today let's start the third concept of the types of forces lesson. Right? In this concept we are going to discuss about remaining forces of the electromagnetic force. In previous concept we have discussed two forces in electromagnetic force. They are tension and contact force, Buoyant force. In the Buoyant force we must know that fluid. Fluid is nothing but a substance which can flow, right? Fluid is nothing but a substance which can flow. Generally, gases and liquids are considered as fluids because they can flow easily, right? Solids cannot flow, right? And next, Buoyant force. Buoyant force is nothing but the weight of fluid displaced, right? This is the definition of the Buoyant force, right? Let's see what exactly is Buoyant force, right? Let's take a beaker and pour some liquid into it, right? In this, we are considering that the fluid is a liquid, right? So, if we take a liquid and we will keep an object inside the beaker, right? And let's see the object, right? There are two forces acting on it. One is the weight acting downwards. Weight is nothing but mg, where m is nothing but the mass of the object, and there is some force acting on the object upwards by the fluid, right? And it is called as the Buoyant force, right? So Buoyant force acts always in the opposite to the direction of the weight, right? And next, let's see the magnitude of the Buoyant force. Buoyant force is denoted with capital B. B is equals to V inside volume of the object inside the liquid and density of the fluid and gravitational force, right? Volume of the object inside the liquid or the fluid, right? And density of the fluid and gravitational force or acceleration due to gravity, right? Volume of object inside the liquid is denoted with VIN, and the density of the fluid is denoted with rho f, and we measure density with the symbol rho. Rho is written like this, right? And next, gravitational force. Gravitational force or acceleration due to gravity is denoted with small g, right? This is about Buoyant force. Next, let's see an example for Buoyant force, right? Let's take three objects are of same volume, right? They are a ball, water packet, and a stone, right? And a stone, right? And let's take three beakers. Three beakers are filled with water, right? And in first beaker, let's drop a ball in it, right? Let's drop a ball in it. The ball will go inside the liquid, like in here, right? But the ball will come up because the Buoyant force is much greater than the weight of the ball, right? So the buoyancy force and the weight of the ball must get balanced, right? So that the buoyancy force will get equal to the weight of the objects when it floats, right? The weight of the objects will remain constant, and the density of water and gravitational acceleration due to gravity will also remain constant. In here, the volume of ball inside the water will change. So here the volume is up to here. This is the volume inside the liquid, so that the Buoyant force will get lower. So the Buoyant force will get lower down, right? So the Buoyant force and the weight will get balanced, right? So in this case, the weight is less than the Buoyant force when it is completely inside the liquid, right? We will generally consider the ball completely submerged inside the liquid. And next, let's take the beaker 2 and drop a water packet inside it. And note that the three objects are of same volume. So we can take this B out. In which the ball is inside the liquid, not floating on the water, right? So we can take this and this out, right? The water packet will float just below the surface of the water inside the beaker, right? So in this case, the buoyant force and the weight will get cancelled. The water packet will float near the surface of the water, because when the water packet goes deep into the beaker, there is some pressure acting on the water packet, so it reaches again upward, right? And the weight is nothing but m, and buoyant force is nothing but the volume of the water packet, and the density of the water which is in the beaker, and gravitational acceleration due to gravity. So in this case, W is equals to buoyant force. It means weight is equals to the buoyant force. So the object will float near the surface of the fluid. And next, let's take another beaker, and let's drop a stone in it, right? So the weight of the stone is much greater than the buoyant force, because the buoyant force will always get equal, because these three are of same volume, right? And next, the buoyant force is same. These objects will float on the surface of the water and sink because of their weights. If there is an increase in weight, the objects will sink. If there is a decrease in weight, the objects will float, right? That's it. And so in this case, the weight is greater than the buoyant force. This is about buoyant force. Next, viscous drag. Viscous drag is nothing but the force which opposes the motion of the body inside the fluid, right? Let's take a body moving inside a liquid. Let's take a boat which is moving in the liquid, right? In the water, right? And the boat is moving in this direction, and the viscous drag is applied in this direction. Means the viscous drag is nothing but the amount of resistance provided by the water on the boat, right? And viscous drag is directly proportional to the speed. In most cases, when speed is small, viscous drag is directly proportional to speed, right? Speed is small means it is not comparable to the speed of light and sound. When it is and this proportionality does not apply when the speeds are comparable to the speed of light and sound. That's it. This is about the concept 3. And this is the end of the lesson, types of forces.
Thanks for watching. Please like, share and subscribe. See you in next video. Bye bye.